Welcome to Rubber Duck Engineering. Tonight we're going to take a turn left and talk about games, which I guess we've done some of. But we're going to analyze a new game that recently came out that I played through this last weekend and wrote a simulator for, as one does. Yeah. Hi, Dr. Barth.
Hey, Eric, you act like this is a turn to the left territory. We've done this like 3 times on the show. Where there's some game that you get excited about, and you build like a simulator because you want to analyze the game. And I think it's fun.
I don't. So I played this game. We'll talk more about the game, but like I was saying to you a little. That's other news. I saw this man in person for the first time in 2 years today.
We had lunch. It was epic.
Howdy. Oh my goodness. I'm sorry to be part of your sleep denial. Oh. Anyways, yes, we had lunch. It was great. But yes, the games, I was saying to you at lunch, I just find games that have like exponential functions in them to be very interesting because my brain just doesn't get it.
I think it's a human thing. Like humans know how to like throw rocks and they can interpolate parabolas or whatever, but we don't know how to throw rocks and have them move exponentially. Just our brains just don't do it.
And so
they exploit this to make games, right? They hit this really hard in games to confuse you.
This game, like so many games, you like build a thing and then it builds for you, and then you like want to build up to them to get to like a specific goal. And we'll talk more about the mechanics in a minute. I should say more highs. We got more highs. Hi, Habas.
Hi.
Yeah, and I find that so interesting. This also was I really like the simplicity of this game.
What is the game, Eric? You haven't told us.
It's in the title. Well, sort of in the title. The game is Planet Crafter. It's a new indie game out of France. Came out last week or the week before. It's written by 2 people. And I guess they've done a few games together, but this is, a game. So I don't know whether it's like a hobby thing, but like a 2-person shop. And it was fun. I played through it this weekend. So
demo. Give us the demo.
Dun dun dun. I bought it on Steam, so this is the full one. But we're just gonna start a new game and play just a little bit so you can see what this is. Survival 5. Yep. Great.
So this is with like Steam early access, right? So the expectation is they're still working on the game.
Oh yeah.
They're refining it, but with the feedback from players, right?
So there's like no story yet. I mean, there's a little bit. You're like dumped on a planet, and your job is to terraform it. And you go outside and you start like losing oxygen, like one of the resources that's down in the lower left-hand corner. You go back inside, you get your oxygen again. You have this like magic gun, like tricorder thing. You have like you can like add mods to it, so you can like build things with it, and you can like pick up stuff. And you go to this thing, and it tells you like, hey, if you want to build stuff, you got to pick up stuff to get a microchip to build construction. So you need 2 silicons and 2 magnesiums. So you go out and find these little silicon things. And here's a magnesium. Oh, that's an iron thing. Probably gonna need one of those anyways.
So it gets like transported into your backpack or something.
Yeah,
we have like infinitely big backpack.
Oh no, you definitely don't have an infinitely big backpack, and that's one thing that I haven't modeled in the simulation yet.
Hey, Morris. Oh, cool. Yeah, I saw the I was going to take a look at it, but maybe we'll take a look at it after the show. Thanks for sending it.
Yeah, that's awesome. And you get some messages to like give you a story. I won't go into all that now. And then once you build a microchip, your thing now has a new ability. Whereas now you can build stuff. You build ability. You can build projects. You build
game is a very advanced.
And then you need to put like a door on it, which is iron, titanium, and silicon.
It comes without a door. That's hilarious.
We can stack them together.
I can see the appeal of this game. Oh, it's getting dark. Do we have to get the habitat going before nighttime or something?
I don't know. It also just told me low power, which is a thing that when I played through it, power was not a thing.
This happens sometimes with these early access games. It's like you play through them and then they change out from under you. There's like a whole new dimension to the game that gets created. Oh wow! Now there's a door. That's so cool.
Now there's a door. And this game has a whole like indoor outdoor aspect, which when I played it in the demo, which came out some few weeks ago, it didn't differentiate, or I couldn't figure it out. So I actually loaded up my demo save in the the slightly more advanced version, and it just wouldn't run because I built all of the inside things outdoor by like exploiting a bug where if you build it fast enough, it'll let you build it outdoor, and it just the poor updated game just couldn't handle it. Okay, so one more thing I want to show you before we jump into like the code is I want to get one of these things, a blueprint screen, which is iron and silicon. As you can imagine, you do this, and your job is to terraform this planet, and you do that by building structures. So we could iron and silicon, and so like
power.
We need like a power. So there, I just out of nowhere, I made a power. That or not.
Oh, I see. Now this thing has lights on because you've got power.
Oh, I see. Maybe it didn't have the. Oh, I hadn't even noticed that. So, like, you build this thing. That's a drill to get pressure. I need one more iron, and then I can show you the blueprint screen.
This sun is like blazing hot. It's like
Yeah, I'm not really sure what the temperature is supposed to be. There's ice all over the planet.
Oh, maybe it's actually cold. I just mean it's so bright, like the whole thing is turned crazy yellow color.
They do that actually in a bunch of different. Like you'll go into like a red cave and a blue cave. They play a lot with.
Hi, Big Vlad. Thanks for joining us.
How things look. Okay, come on. Show me an iron here. Maybe in my simulation I had to pick a number for like how long it takes to go get a resource. I may have picked too small.
But the resources don't respawn, right? It's like the more you harvest iron, the farther you have to go to get more iron.
Maybe you saw that I said that in the code. I saw that in one of the like change logs that was a thing, but I don't actually know whether that's true or not. I think I've seen some resources respawn. I think if they do respawn, they respawn at a really low rate. There's an iron right there. You can see it flashing. So once we have this, we go back to our shelter. And you can upgrade things to like make you run faster and things to make you fly, at least fly a little bit. That's what I want to show you, this blueprints thing. Once you have the screen, you can then see all the things you can unlock.
Oh, this is like the whole tech tree, or at least part of it.
Yeah, it's a big chunk of the tech tree. So what you're trying to do in this game is you're trying to increase this number, this terraformation index, to a certain value, and then like both you unlock new things based on this terraformation index, as well as that's just the like goal of the game, but it's like orders of magnitude. So like right now I'm increasing it by 1 nanopascal.
Nanopascal
per second.
Okay, it's gonna take a long time to get a pascal.
And then similarly, there's heat, which you increase by a picokelvin, and oxygen that you increase by a part per quadrillion. I had to figure
part per quadrillion.
Part per quadrillion.
These units are amazing.
Anyway, so that's like the basic premise of the game. And once I did my playthrough,
Big Vlad says they do respawn.
Oh, good.
The resources.
Yeah, they do.
Cool.
They do seem to sometimes. What I was interested in is trying to understand what a speedrun would look like, and I went looking for one, and I found a couple on the internet, but they didn't seem that fast.
And define speedrun, or not all our viewers may know what you mean by that term.
Well, it's true. So a speedrun is where you try and do a game as fast as possible. So like if you ever played, if you're my age and you played the original NES and like a Super Mario or whatever, like people can beat that thing at 4 minutes or 5 minutes or something like that.
I think it's really serious for games like Mario. Like they're like world records, and like you have to submit video proof of your run and things like that.
And they're down to the frame, for games like that when you're like a 4-minute run.
But you wanted to figure out like what is a strategy for this game that gets you to the end, or that gets you to some milestone as quickly as possible.
Well, because and this gets back to the, I don't know if it's exponential or, but the like cumulative effect of like once you build a thing, it is producing for you forever. That's another thing I like about this game is it's very simple. A lot of these games, like you build a power source and then that power source only works within like a certain radius or whatever. Or in this game, it's just like, no, you build a power source, it works anywhere on the planet. Which I'm sure is simple to code and also simple to like understand. So if I go back to this, like a question I could ask is like, which one of these things should I build? Like which gets me the most for like the time in game that it took me to like increase the heat?
And the main limiting factor is like we saw you running around collecting like rocks off the ground. Is that the main limiting factor?
That is the main limiting factor. There's very late in the game, you do a little bit of farming where you like build a thing and then like you plant a seed and like you wait the seed to get bigger or whatever. But actually physically collecting resources. Later, not so much as with specific things. We don't want to go into that detail. First playthrough. Oh yeah, no, I've played through, but yeah, I don't know that we need to spoil it because the game is a lot of fun and folks haven't played. Again, it's a tiny studio in France and they clearly poured their love into this game.
So you built a model of this game. Should we take a look at the code you've written?
Yeah, let's pull up the code machine here.
To the code machine. We need to get t-shirts made. The code machine.
So I did post in the Discord channel for this. So if folks have shown up tonight expecting to play through the game, we're actually probably going to more play through the code because that's what we tend to do here.
We will analyze the game in our own way.
So I gave Dr. Barth a preview link. Yes, I agree. Big Glad, it sounds like, has played this game. He's saying, I'm glad they don't have wires to manage. Yeah, other games, they make you manage wires. And like this game is much more relaxed than that, which I like. So the code that we're looking at right now is github.com/eastsidel/PCS. That, if you want to follow along at home, we'll also put it in the show notes. Yeah, so I built a very simple model, which like has a world idea, it has a time, it has a total progress. I made up this progress thing.
Is progress supposed to model the terraforming index?
Correct. It models these individual components, but then it knows how to create a terraforming index from this.
I see.
This was actually a lot of fun. I can. Some of this is I just like writing this kind of code. So like if I show you, maybe I'll show you this now. But like I got to write these. I got to write these constructors. So like
I see, because the game operates over such a huge like orders of magnitude. There's like kilo and mega and giga and tera.
And then it's fun because they express all their goals in these things. So for the TI one, I didn't actually write that many different ones. But for like oxygen, right, they express things in parts per quadrillion and some goals in parts per trillion or parts per billion or parts per million.
The parts per trillion are hilarious. I guess Big Vlad is did a 22-hour stream.
Oh my goodness.
If you just finished that, maybe you should take a nap. I don't know. You have way more streaming stamina than we have.
Yeah, we do an hour a week. But so I wrote this a couple days ago. I just love writing this kind of code. Where it's like I wrote this little DSL basically where I have a custom constructor that makes quadrillion. And then I wrote a special toString that knows how to print back out in like the right units. I don't know. To me, that's kind of fun. Anyway, so it does progress. It does this item counts. This was also fun to write. I have this very basic idea of the items, like the iron and aluminum and stuff that you can find on the ground. And then where a lot of the effort is in modeling these structures that you build. It's not, I mean, the piping and the structures isn't hard, but modeling the planning around how to decide which one to build is the interesting part. Because the speedruns I've seen to the very first milestone are like an hour, and I wonder if it couldn't be half that.
Because you have to like optimize the order in which you build all these structures and the resources that they require. Oh, so it costs energy. So like to run your drill, you have to power it. Oh, interesting.
But that just is more resources to get, right? Because the energy, so like to power your drill, it costs energy. But that's just a wind turbine to solve your energy problem.
So how did you find out that the drill like makes the progress go forward by 0.2 nanopascals?
When you walk up next to the drill and you hover over it, it says, "Oh, I'm doing this."
Oh, I see. You have to study each of the objects. Oh,
Yeah.
okay, good. I'm glad you got some sleep left.
But yeah, so I wrote, just like you've seen us do in the HTML parser project, or I wrote one of these, like basically a golden file where I run my simulator and have it make decisions. So here,
How does it decide what to do? Is there, you have a decision function somewhere?
Yeah, so if you look at PCS, this thing, so we had started here. So you have this world that like holds the state of things. Mm-hmm. And I followed the immutability pattern that we've sort of stumbled into. There's this concept of an action, which is right now either you go gather something or you build something. Like one of the things we could do, maybe we'll do tonight, is the idea of destruction, because like I haven't modeled that yet. Hey, Static.
Yeah, thanks.
Nice
Glad
to
to
see
catch you too.
And then I have an actor class, which is super simple, and we did something like this in one of our earlier game models. And then actors can generate a plan, mm-hmm. or at least this one actor will generate a plan, because the actor model's kind of evolved a little bit. You were saying?
No, and there's like time is somehow modeled synthetically. I saw there was like a time modeled as a double. That's like,
yeah, time is it's not the simulator is not real time. So time is just whatever you tell it is, and
like an action has a cost, which is like how long it takes or something. Is that the idea?
Yes. So the only things that really affect things are what is the current. Basically, the only thing that affects things are structures. And then from the structures, you can compute the progress delta. Like you can just add up all of their, like, how much oxygen they're producing, how much heat they're producing, how much whatever. So you can add that. And then if you want to advance time, you just advance time that far and you multiply the delta and you add it to the total progress.
So the total progress is like the integration of all of the deltas.
It itself is just a progress, but yeah, it's the accumulation function. Resources can be a huge bottleneck, and balancing the prioritization of certain resources versus power production can stop you in your tracks. Yeah, exactly. But that to me feels like a math problem that like should be solvable. And
it's like this is like theory crafting, right? Like in World of Warcraft, people would always like figure out like what is the right sequence of spells and buffs and debuffs. Like, mm-hmm. This is just like I've seen that done with spreadsheets for World of Warcraft, but this seems like a like a more complicated equation that requires a more complicated tool in a spreadsheet to theory craft.
Well, if you look at it, so I wrote some helpers. I feel like I've sort of lost the narrative. Let's see. Did we get? You asked how decisions were made, and the fact that. Go ahead, sir.
Oh, I see.
Yeah, it took me a while to figure this out, but I think it turns out all resources are renewable. It took me a very long. I got stuck for a long time having run out of uranium and not having any ability yet to get more uranium.
So I mentioned I saw that some of the resources are not gatherable. You just have like machines that produce them and shove them in your backpack, or where do they come from?
Yeah, so uranium is actually gatherable. There is some of it on the map, but it's in like secret locations or whatever. Some of these things are found in like other spaceships. There's a bunch of downed spaceships, and if you crawl around inside them, you'll find some like rare resources in them. A lot of these are craftable. So like fertilizer requires certain sub-resources. And because I didn't do that part of the simulation yet, because that's like much later that you would use a resource like that.
I see. So instead of building a building, you can build a resource sometimes.
Correct. So and in fact, some of the unlocks that you get are unlocks of resources. Like, this resource is now findable on the map, or this resource is now makeable in a machine, or
So how far have you gotten? So I saw you had an actor or a planner. Does it like make a random plan, or how smart is it?
Oh yeah, I'm actually quite far. So I did the random planner. That one was early. That didn't work very well. I did a slightly smarter planner.
Did not terraform the planet correctly.
Not terraform the planet. So if you look at simulate.dart, so this is the script that knows how to run the whole system. It's like the entry. Big Vlad says he ran into issues with uranium too. Yes, it took me a while.
It's true on Earth as well, by the way.
True to real sky, or true to real world. So they have these stages, which the wiki is very new because the game is very new, and so not all the stages are like written out. So if I play through this again, I'll write all these things down. But Blue Sky is the very first stage. It's the stage that you can get to in the demo. If you download this for free, no money, you can play the demo up to Blue Sky, and I think maybe ever so slightly past that. So that felt like a thing to speedrun towards. And so that's what this simulate thing does, is it says, hey, let's grab the Blue Sky stage. Let's figure out what the goal is, the TI goal. We'll make a goal object with that. We'll shove all our output in this file. We'll say that that's what we're doing. We'll start with an empty world. We'll make our actor, which this was, again, my like third or fourth one. So I happen to call this one Sprinter. I could just rename it to my like planner actor. Let's build up a place to shove all the actions. This is just for logging, so that you log ever so often. I could probably remove that now that I'm not just printing at the console. And then while we haven't reached our goal, we plan one action using this actor and this world state towards this goal. And then we take out the new world and we log the action. And then I write what we did. This is for my log. And then ever so often I log more stats. This is again kind of holdover.
Can we dig into plan one action? That seems like that's where the smarts are.
This asks the actor, again, this has been like refactored 3 times. And so some of this could probably be deleted now or like simplified. But it just calls us choose action on the actor, and then calls apply action. So choose action, our actors currently, I said they work in terms of plans. The one true actor does, but this one works in terms of, the interface works in terms of actions. So if we look at Sprinter, this is the one true planner at this point. When you say choose action, it first sees if it has an existing plan. And if it does, it basically, this is like an iterator where it just moves to the next action, gives you that action, and then it's done. Otherwise, it'll clear out the stale plan that it's already walked to the end of and find a new best plan.
Okay, so I'm trying to find the smarts. So find best plan sounds like where the smarts are going to be hiding.
So this will calculate the current time to goal from where we are.
Oh, Vlad had another question.
Oh,
is there going to get more fabric?
Oh, interesting. I don't know. You're right. I have a chest of fabric, and I've just never. I didn't really get into the I'm going to put a chair here and there clearly is a build a beautiful base aspect to the game, which I didn't really engage with. You see, here I'm writing simulators and thinking about speedrunning.
It's like for making, because if you're living on this planet a long time while you're terraforming it, you need a comfortable living room to hang out in. Is that the idea behind the fabric?
Oh yeah, they clearly have that half of the game. You could half the unlocks are what I would think of as cosmetic unlocks. And it sounds like Big Vlad. And again, if you look on the internet, people tweeting about it, they built beautiful big bases and whatnot. I just didn't get into that part.
Sometimes it's for these early access games, they're starting with the core game, and you can sort of see where their ideas are going. And by the time they finish the game, it does way more than what the first week was.
Yeah, I actually really enjoy that people can look at the same piece of art, because games are art, or at least they are in my mind, and just get totally different things out of it. Anyway, so this is a source of bugs, or was a source of bugs. I didn't quite handle infinite correctly.
So time to goal means if the current structures keep doing what they're doing and we don't do anything else, correct. How long until, okay, that makes sense.
And so then for each possible non-energy structure plan, so these are unlocked non-energy structure plans. I probably should rename it unlocked, because the energy structures, we don't need to plan around them. We just plan around things that will change our progress rate.
We just have to build enough energy structures to power all of them.
Correct. The energy structures are just support of the. Then we do we do this calculation, and now we're getting to more smarts. The time to goal with plan.
Okay.
So here for, let's see, what is this? This is, we make a new structures, because again, these are immutable objects. So we're just making a copy so that we can for each of the actions in the plan that has a structure in it, we add it to that. Why did I do this? What is this doing here? Oh, I see. We're just making up a new world.
Yeah, you're sort of like saying, if we execute this plan, let's drive the simulation a little bit and then figure out how long it's going to take to get the goal.
Correct.
That makes sense.
And so, and if we go back to this, we get the new time to goal. So it's like, if we execute the plan, this is the new time to goal. And then this is the like EV, the expected value, is the time to goal delta. How much improvement are we getting in our progress per second that we spent on getting to that progress? I don't know if this is the right, but this is basically the fitness function.
So when you say possible non-energy structure plans, this is like, I'm going to build one more structure.
I'm going to start with the intention to build one structure, but I might have to build 18 if 17 of them are energy producers.
I see. So it's like, I want to build the nuclear power plant. So I'm like, okay, here's all the things I need to do in order to arrive at the nuclear power plant.
Well, the nuclear power plant is just an energy thing, but I want to build a heater.
A heater, okay. I'm going to build the super fancy heater. And I need to do a bunch of prerequisites to get to super fancy heater. And then once I have it, it's going to be amazing. It's going to power terraform.
Yeah, so if you go up to the plan builder here, that's exactly what it does. So it's like, I do plan for structure. I like, if I already have the energy, because this is actually important that you hold, that you, and my earlier iterations of my planners weren't this smart. They didn't know how to like understand what the current world energy was. They just always built, imagining there was zero world energy. But this is actually important because sometimes you just produce excess energy. And like, you don't need to like
build too much extra. Okay.
Yeah, you want to just build, if you have existing energy, you want to just use that because that's way faster, right? So if we need energy, we plan for energy, and there's some decisions made in there, and we can look at that in a second. Otherwise, we just plan for the resources. So this is written generically, but right now all it does is just execute a gather.
Oh, you walk around with a gun and you suck them up into your backpack.
Correct. But there are other ways you get resources, including things like destructing other buildings, which might make sense,
I see.
Or, going in one, or, growing one, or like synthesizing one from other smaller resources and things like that, right? So there are other ways that this could be done, more exciting later in the game. But yeah, plan for energy and then build structure just executes the build command. Plan for energy, there is some smarts here. So we look at all possible energy plans and we compute a similar metric of how much extra energy per second am I getting for the time that it took me to do that. And the time includes like the gathering and stuff.
So this basically strikes me as a greedy algorithm approach. At each step, you're saying, what's the best step that I could take at this moment to like seek the highest velocity towards completion?
Correct.
And is that, do you think that will find the optimal plan, or are there ways in which there might be a better plan out there if we considered more factors?
So I know for a fact that so I have evidence to suggest that this does not find the optimal plan, for one. And one of the things I know it doesn't do is it doesn't undertake subplans. So like the goal plan is the get through blue sky, which is some terraforming index goal, some large volume of terraforming index. But there's a bunch of sub goals you could have to unlock a better heater, or unlock a better drill, or unlock a better power source along the way.
I see. And so it's the unlocks. This thing is not trying to optimize to unlock good structures. It will just accidentally unlock them as it tries to drive the terraforming index.
Mm-hmm. And in fact, so this happened in like a couple commits ago. I had this bug where I didn't. So some of the oxygen generating things, you have to put a plant inside them for them to work. You can build them without them in the game, but you have to put a plant inside for them to actually do anything. And so in just transcribing from the game itself, it's like, oh, it doesn't talk about plants. But for my logic to work, I need to like have a plant be a requirement. And so it was like planning and building these things that were generating oxygen. And then I added the plant requirement, which in my little structures you see, I tell it that going to get a plant takes you like 60 seconds, which is where is it? It's like plant. Come on. Maybe it's over here. This. So this function is super important. Gather time for this.
Oh wow, it's like orders of magnitude here, like 560 and 360.
And I just pulled these. I just imagined these, but I suspect that whoever designed this has a spreadsheet with a similar calculation.
Because they decided on the spawn radius or like where these items should exist on the map.
Or just, again, and probably not this sophisticated. Maybe they didn't. Maybe they just... Would this builder cannibalize the base to reach the outcome faster? It doesn't yet. That's actually a thing that it should be taught how to do. But that's an excellent question, Big Lad. Because it doesn't know how to upgrade things. Like the energy structures, they seem to be designed so it's like, oh, you just need one more aluminum. You tear down your old one, replace it with a new one with additional aluminum, and you're good to go. Anyways, I don't remember what I was saying.
It seems like it'd be pretty easy to add to the design that you have here, because you already have the idea of like, oh, how do I get this resource? And you have the idea I could gather the resource, but they could also look at maybe I could destroy something else, create the resource.
Totally, and it would take a little change, but yeah, I thought we could do the adoption agency last week and we didn't. So I don't trust my estimates, but
engineering estimates are off. What?
By orders of magnitude. For those of you just tuning in, we are both spent many years as professional software engineers.
Making bad estimates for how long it takes to do things.
Anyways, this function is very important because it controls the whole. And so I actually wrote some here. If we look at this terminal, so that's the TI structure value. Let's do the energy structure value. So this is where I just looked at all of the structures that I have typed in. And so this is solar panel T1, or wind turbine. That's the one that you saw me build in the game, right? It takes, on this model, it thinks about 6 seconds to build, 1 second to actually do the building, 5 seconds to go find an iron. And it produces 1.2 energy. And so the ratio of energy produced per second to the time it took to get that is 0.2.
So this is a bad structure to build. Like it's way better to build solar panel T1.
Well, you would think that if they were designing the game, they would make it so that each structure was more efficient to build. And
so as you unlock them.
Yeah, you'll see in my current simulation that this is not true. That it is currently, my current simulation thinks that T1 solar panels are more efficient to build than T2 solar panels.
Vlad has another question here.
Could you also add in prioritization for agility upgrades? Yes. So that is definitely something to. So what Big Vlad's alluding to is that you can build these little chips or whatever to make yourself run faster or fly a little bit or whatever. And I think that you totally would want something like that in the gather model. Again,
I see, because that would reduce the gather time for each of these resources because you could find it more quickly.
Correct. And there's mining chips to reduce the mining, but again, I think as you make a more and more sophisticated model, which I think I made good progress, but there's another week of hacking a little bit. I kind of want to run through the game again, some weekend, but I kind of want to make the model sophisticated enough first so that
if this thing printed out a plan, if you then tried to play the game with that plan and be like, oh, I realized that this plan doesn't really work.
Yes. Yeah. Because anyway, so this simulation is clearly, or I read this data. So these ones are infinite because I haven't taught it how to get the necessary required materials. But I read this data and I think the simulation is wrong, because I think the game designers would definitely have designed solar panel T2 to be a more efficient use of time to build.
Well, that may be because we haven't modeled the destruction. Maybe what we were supposed to do is destroy your T1 to make a T2. Because if you look at the energy production from the T2 solar panel, it's significantly more than the T1. And the time estimate is where the ratio is losing out.
And where the ratio is losing out is all because the time estimate includes aluminum, which I may not be modeling aluminum. Aluminum is the first semi-scarce resource, second semi-scarce resource. the first semi-scarce resource is iridium. You have to go like find an area of the game where there's like iridium on the ground, and then otherwise you're just finding aluminum sort of randomly, occasionally in ships and stuff. But then there's also another area in the game where you can like find aluminum on the ground, and kind of once you do that, then aluminum it's not easy to come by, but it's way easier to come by.
When you play the game, do you tend to like then move to the aluminum rich area to build more of your structures because you're kind of at the aluminum phase of technology?
So this again is like where it's art, and I'm sure different people play it differently. I'm sure like if Big Vlad and I give you notes, like he or she, played it completely differently than I did. But I sort of dropped those little one unit pods everywhere so I could recharge my oxygen. But otherwise I would go wandering, and you can build a bigger and bigger backpack, which again, like the backpack is not being modeled in this as well. But I did a similar investigative for the structure values, and this one I actually did some tuning to make these make more sense. So I don't remember how I have these sorted at the moment. Oh, I have these sorted by TI.
So like when it unlocks.
Yeah.
Okay.
And I did this actually because one of the things I was looking at was making a subplan, just like making a manual subplan and teaching my planner how to use it and see if it got any faster. But if you look at this, if I just go back in this, structure values, it changes to sort based on progress per second ratios instead of the TI unlocks.
I call it a 1 unit pod, an outpost. Ah.
Yes, exactly. Oh yeah, totally. I have outposts everywhere. So the idea here was to just look at what the TI delta over time ratios that my simulation was producing. Like, what is the absolutely most efficient thing to build? Like, if you had everything unlocked, what would you build? Mm-hmm. And I did some tuning to make these make more sense, because there was a time when like the drill T2 was more efficient than the drill T3. Which again,
the tuning you did was to the gather time for the resources?
Correct. Uh-huh. That's really the big tuning factor in the simulation. Again, the simulation's not good enough. Like right now, it has a fixed time for each gather, which is wrong. That's not how you actually play the game. You go sort of like on a gather and you like pick up a bunch of things. So like your time to go out gathering is like a fixed time, and then the picking up individual things is a smaller time.
I see. Like you should plan like a gather event where you'll go collect resources.
Correct. Mm-hmm. Which then is limited by your backpack size and limited by your oxygen tank size. Like how long or how far can you go?
Yeah, I mean, you have to simplify some things to build these simulations, right? There, like you have to figure out like what is the essential complexity of what's going on that then has a big effect on what your plan ought to be. It seems like from like at least what you described so far, it seems like taking into account these unlocks, like planning for them. You're like, oh, I really want to get the heater T2. So mm-hmm. like, I mean, instead of my end goal being blue sky, I now have a sub end goal of, whatever it is, 1.9 kilo terraform index.
Mm-hmm. Yeah, that's you've hit the nail exactly on that. That's where my brain was too. And so sort of my next MVP, the next like little thing that I'm was going to try and code into the simulation was just a handwritten subplan, and see if a handwritten subplan.
But like what algorithm would you use? Like how would you think about, like I understand the greedy algorithm, right? You look at all the things you could do, you pick the one that seems best now. Right?
Sure.
So what kind of algorithm would you use to plan for these unlocks? Like how would that work?
So where my brain was going, so again, I was going to manual plan first, but where my brain was going for automatic planning was one of, you consider the thing, it's like relative value at its unlock point. So you simulate the world as though at its unlock point, you made one of those. How much time did that save?
Yeah, I just want to be like, I feel like I'm reaching for dynamic programming, and I'm just not quite sure how to apply it in this context.
So I think you can do dynamic programming. You have to make a little bit of simplifying assumptions. The trouble with it is the leftover energy or the leftover inventory between things, because it makes so they're not idempotent or whatever the
yeah, but maybe you could use that for like a rough plan and then use greedy to like tune it a little more. Flower spreaders versus tree spreaders. Is that something that we could, like, in 20 minutes we could code in and get an answer for Vlad?
Possibly. So here's flower spreaders versus tree spreaders right here. Flower spreader time, and I don't think I did tree spreader ones. I only did tree spreader 2, so we could add tree spreader ones. I think tree spreader ones were a biomass unlock, and so the wiki isn't updated. It doesn't have a lot of this information, and the game, you only get some of this information at some times, and then you lose it later. Like once you unlock things, you can no longer see when they were unlocked at.
And some take notes. Do a very careful playthrough where you record all the information you need.
Yes,
I guess that's why people make game wikis, so that, like, we can share this work among the community.
And so that blueprint screen I showed you shows you all of those unlocks, right? And we didn't have anything unlocked, except there's a second and third blueprint screen for different flavors of unlocks. Maybe just second. Anyways, there's another blueprint screen at least, which
shows you more advanced things on the tech tree.
Yeah, it's like a little side tech tree. I don't entirely know why they did it that way. But there's like a fourth resource that they introduced kind of like late in the game. And once you get to the fourth resource, then there's like a separate screen that shows you the fourth resource's unlocks. And so that's what Vlad, I believe that's where the tree spreader came. But if you look, Vlad, the TI delta.
Oh, yeah.
What you say?
No, go ahead.
One of the things that makes this all so confusing is also the unit types. So when you're playing the game, it always reduces things to small units. But then I couldn't keep in my head whether parts per billion or parts per trillion or how that mapped over into the TI space. As far as I can tell, there's no like breaks. It's all linear. It's just that the units change out from under you. Without coding, I've found some overlapping efficiencies between the two where it makes sense not to use the more advanced tech.
Interesting.
That's what I'm expecting too. Is that there are holes in the.
But here it says like for the tree spreader, it's a kilo terraforming index, but for the flower spreader, it's only 7 terraforming index. Oh, tree spreader T2. It just sounds like it's like almost 1,000 times, like, has a bigger effect on the terraforming index.
Which would be expected for a T2 versus a T1. Like they're generally order of magnitude or 2 order of magnitude jumps.
I see.
Because again, you're going within the game, you're going like 7 or 10 or something orders of magnitude in terms of total. So like these T1 stuff are just total drops in the bucket, at the end of the game. So
I wonder if, like, maybe the way to do the algorithm is you look at all of the unlocks, right? Mm-hmm. Like, or you look at the earliest possible unlock, and you're like, okay, let me create a plan that gets me to that unlock as fast as possible.
Sure.
And then I use that as the construction time for the first one of those buildings in my plan, right? And then if you like go through the unlocks in order, then you should be able to compute optimal, using the greedy algorithm, compute optimal times each of the unlocks, and then add that to your database. Like, that's why it feels like dynamic programming to me.
Mm-hmm. No, I think you're right. I think you're.
Oh, the T1 tree spreader. Sorry, I haven't actually played the game, so I only know exactly what Eric has just said about the game. So my apologies.
I think that you're right, that it does end up boiling down to a dynamic programming like, because I think you can ignore the energy, and I think you can ignore the inventory, that you just always assume you have 0 excess energy and 0 excess inventory, and you just have to always gather everything from.
No, I think you want to consider those things in your greedy plans, but
sure,
like you may not need that level of precision to plan the next unlocks.
Mm-hmm. And I think that you're right that you end up. I think you can evaluate it as though you've unlocked everything and think what is the most important thing to build now.
Oh, I just think you could just compute a database of all of them, right? In the same way you have the idea, I need to gather this iron in order to build this thing. If you imagine, like, there's a different kind of cost for the first one of these things. And the cost is I need to gather the TI to build the first one.
And it feels to me like it ended up being path planning. Like your Dijkstra's or whatever, where you're just you're planning from unlock to unlock, as though the unlocks themselves are nodes.
Mm-hmm.
Two tree spreaders are when it starts to make sense again. To me, it seems like if there's an intentional plateau made by the dev, and I feel like there are a few of those in the game. I feel like
I
when
can't
you
imagine like designing this game. Like I don't really just like hand tune all the things and make it feel good, or whether like do you think that the designers have this program on their end and they've like adjusted it all to actually make sense?
I don't think. I mean, it's like one or I don't know, but I don't know if both of the individuals are do the code, or if it's like one person does the code and one person does the art, because games are so much art. And so I think that it may just be one person writing code.
Well, sometimes you see this in these games where they do like game balance updates because they found like, oh, everyone is always doing tree spreaders and they're ignoring the flower spreaders, and that's not what our intent was. So let's adjust the costs to try to.
By the time you get to the tree spreaders, you're kind of into the area of the game that feels unfinished. Like, because you get to the end and there's like 3 stages at the end where there like isn't any content. There's no new content or stuff that you unlocks, but like the thing will say, hey, you reached the next stage. And so, and that's about like the tree spreaders are like well into that area.
So maybe they haven't been tuned and adjusted to quite fully be balanced and have a like ideal experience yet.
There's another interesting, so yeah, to me it feels like a path planning problem, and I think that's like the next stage.
Yeah, because like sometimes like you may go down this path for planning, but you may eventually find a totally different route, right? Like imagine this wasn't well designed and there were just like buildings and technology that are not really useful on the optimal path.
Sure.
Right.
Which may very well be
true. You kind of discard those plans.
Well, and actually, assuming you type everything in, and I have here listed some in the structures thing. Yeah, so I typed in a whole bunch of stuff like, do you need the progress screen? No, but you might as well type it in, and then your algorithm should be able to say, oh, well, the progress screen doesn't actually help us.
That's a good unit test. Like, did the optimal plan have me build the progress screen?
And you need a more sophisticated simulation to care about some things like exoskeletons, which allows you to have more of the like microchips.
Oh, I see.
Right, because you have like a backpack capacity, which is for stuff, and then you have like a microchip capacity, which is like for construction and move faster and bigger oxygen tanks and yada yada yada, that kind of thing. So, anyways, I don't think we're actually going to end up writing any code tonight. Oh, I should say there's a very interesting part of the game later, which I haven't yet fully understood, where the game UI tells you that it makes it makes things go up 1,000%. It increases global output by 1,000% of one of the 4 resources. It doesn't seem to do that. It doesn't seem to actually be a 10x. If it was, that would always be the most efficient thing to build, possibly, because it's better than it's as good as building 9 copies of everything you have.
I see, which is a lot, presumably.
And so I think what it actually is doing is it's adding 1,000 instead of multiplying the current multiplier by 10x or by 1,000%. I think it's adding 1,000% to the total multiplier. So thus, when you make one of these things, you've effectively multiplied by 10% or by 10x. But then when you make the second one, your total multiplier is 20x, not 10x. It's not 100x rather.
So do you have a save game in a more advanced game state that you can show us? Like, what does the game look like when you've gotten some progress through it?
Sure, and Big Vlad can tell us how ugly my base is.
Did you build any chairs? Can we see your chairs?
I have not built a single chair. Okay, let's see. Let's remove this. I do know they exist, but I have not built a chair. We're gonna have a lesson.
We could break new grounds. We could build a chair.
We could build. I have the fabric. We could build a chair. Oh,
I see. This thing is on like a giga terraform index. Is that a lot? I feel like Kirk from that's the Star Trek movie where he's like, is that a lot?
Well, you find yourself asking that question when you play this game. Is that a lot? Is that a little? Like, who knows?
Whoa, is this your base? This is so huge compared to where we started.
This is a tiny base, but
this is a tiny base. It's got like how many different rooms?
Oh yeah, they're all like these are all single rooms. You can also make like 2x2 rooms. Again,
yeah, but I had the same problem in games. Like whenever I played like the classic Final Fantasy games, right? And you get the elixir potion, which is this amazing potion that like totally heals you, but there's only a finite number of them in the game. You can't buy them, and so I would just never use the elixir potion because I knew that I might run out.
So to rest easy, Vlad, I believe you can always deconstruct everything. So
and do you get back all of the stuff you put in it? Like
you get back all the stuff, and so all the buildings you can. So I made a distinction in my simulator between structure and items. I don't think the game actually does that internally. I think it's all just one mess of items, and I should probably fix that in my simulation. But all the like standing things, you just have this deconstructor.
So those like giant refrigerators, are they like full of like biological items or like?
These are giant. These are backwards. This one is the frontward, but yes, it's basically a giant refrigerator.
I love it.
It's a giant backpack, right? Inventory.
You got mushrooms. What else do you have in here?
Mushrooms. I got plants. I got fancy. I got microchips because I've unlocked all the microchips, and there isn't more microchip content yet.
Why are you storing the microchips in the refrigerator?
It's not actually like there's no temperature of these things. Oh yeah, you can deconstruct and recycle, but I don't know. I just keep it in the locker. Yeah, no, I hear you. I have this is my fabric, and I have another locker on some other base that has a little bit of fabric in it. There's these funny little things.
Golden effigy? What is that?
Right click to build.
Does it go inside or outside?
It's a cosmetic item.
Okay. Maybe this is a picture of your rocket that took you here.
Maybe. I think it's more a joke. That's what it is. Oh,
it looks a little bit like the Blue Origin, like Jeff Bezos rocket.
Oh no! Did I just put a rocket in the middle of my walking space and I can't deconstruct it?
Oh, I thought it had trapped you like in the corner and you couldn't get out. Well, why can't you deconstruct it?
I don't know.
Can we go outside? What does outside look like?
I'm gonna exit. It doesn't seem to save automatically. So let me see if I made my rocket go away. My ill-placed rocket. Yeah, okay. I made my ill-placed rocket. So outside, this is one of the game things.
Whoa, so many machines.
Really well. Is like when you start, this is all red.
I see. So blue sky like turns the sky blue and makes you feel like you did something to terraform the planet.
And this area, all this like lowland here with water in it, is where you start in the game.
So does it like flood your buildings? Are they like underneath the water somewhere?
I picked them all up, but like we don't have to go very far under the water.
Because I imagine a solar panel underwater is not going to do too much.
I don't think it actually tries.
Vlad says you can either left or right click it, but you don't deconstruct the golden effigy. You pick it back up.
That's wild. Yes. Forgive your French. That is correct.
Oh, this is your original thing? This is where you crash landed or whatever?
This is where you started.
And can you pick this up? Or is it stuck there?
No, you can't. I think I could probably empty this and get this thing.
Can you put the whole storage unit in your backpack? But does it have to be empty, or can you like load it up with stuff and then put it in your backpack?
You appear not to be able to get this. You can deconstruct storage units. You'll find those little storage units all over the game, but you'll see like they sort of like make the textures green, which is just so cool.
Because of like plant life is starting to take hold on this planet.
Yeah, there's like a whole algae stage and like a moss stage, and then like branches start to grow. And what Vlad, I'm assuming he based on the name, was alluding to with the trees, like you can make trees and grass spreaders. And there's no loading.
Like literally spread grass. Like it'll show up in the world as grass that now exists on the ground.
Mm-hmm. They've done a remarkable. I mean, maybe this isn't remarkable anymore, but games have done it for the last 10 years. But it's just nice. There's no loading screens.
Mm.
It really feels like an open world. They also done a really nice thing where the edge of the world doesn't stop you. there just aren't any resources there anymore. So you could probably like just keep going and maybe fall off or something. I don't know. But it just very much feels like, oh, okay, I'm like out of the useful area. I guess I should go back to the useful area. But they do it so very subtly.
Is the map always identical every time you play, or is it randomly generated somehow?
In their latest blog post, I'm about to run on it air. But in their latest blog post, they talk about how they'd like to explore procedural generation, but right now they're doing everything by hand. I agree. MVP ship thing, right?
I think that's a really great thing about Steam Early Access is you can really ship games that are still work in progress, but like clearly playable and enjoyable by people.
So it actually was frustrating me. One of the things I didn't like about the game when I first played the demo was when you pick up things. Many of the toothbrush journeys, as we would talk about in sort of like Google Planning speak or whatever, aren't great like that. Like the thing that you do constantly in the game of clicking on a thing and having like sucked in your thing isn't that great of an experience.
It doesn't feel good. You mean like what is the bad part of the experience?
It doesn't look good. Sometimes it's buggy. Like it just sometimes the like graphics get all distorted and like it looks like it's beaming out from the far left. You would think that the thing that you do in the game 10,000 times.
Yeah, you would spend 10,000, well, maybe not 10,000, but like 1,000x the effort of making that thing, that unit of action enjoyable.
But what they have done is instead of spending on the toothbrush journeys, they've spent on the critical journeys, which the other kind of critical journey that we would talk about, which is like just the like completion journey, the thing you have to do once, like the install. Like this game has never crashed. This game, I've never gotten stuck anywhere. They've sort of like thought of all the like, let's just have a nice relaxing experience. The animation is just but there are death bugs. Yeah,
that's what you sort of expect for this kind of stage of development.
Like sometimes you can clip through the walls, but like you never get stuck there. Like sometimes when you crawl up on things like this, like your head will get stuck in the not like stuck like you can't get out, but like sometimes you'll end up looking through the wall, which happens in any of the 3D games. Speaking of speed, there you just saw it. Speaking of speedruns, by the way, some of the best and most interesting speedruns to watch are early 3D games.
Because you can clip through walls.
So many collision bugs in early 3D games.
I'm just impressed by the sort of, I guess I'd maybe say the art direction. Like all these items, they feel like things that you would use to terraform a planet. Like,
yeah. Well, again, I think it's like, whoa, did it hang? I think it's like a one artist, one programmer team, and so I think they're spending a lot of time on art. This is like you can crawl inside these spaceships, and I've already like looted this one. You have a little light, like get stuff from it.
Like sneaking you advanced materials.
Yeah, that's initially how you like get aluminum and get additional plants and stuff like that is through that kind of thing.
And what happens when you run out of oxygen? You just like keel over and reset the game?
They do it actually pretty nicely where the game, like it gives you these beepy warnings and then your like heart beats faster, the like heart sound. And then you kind of like black out. And then you just respawn. But you do a nice job. Here's like one of the outposts, as Vlad was saying, you build lots of these.
Yeah, it sort of seems like Minecraft and the like resource gathering building thing. But I always felt, well, this thing has a clear objective. Like it's make this number go to 1 billion or whatever.
Yeah.
Well, cool, Eric. Thank you for sharing this game with us, and thank you for showing us your analysis program.
Yeah, I just get obsessed about these things, and when I'm not doing my day job,
and I feel like each one you do, you're clearly getting better at the technique of doing it, right? Like you've found the immutable pattern, you have the simulator thing, the planner, the like selector, like you sort of found the main pieces of this problem, and each one you do, you're sort of applying the pattern and getting better at it, which to me is an enjoyable part of doing projects, is that like, feeling this feeling of progression and getting better at something.
Yep. Anyways, wonderful to see you as always. It was amazing to see you in person. Yeah,
thanks everyone in the chat who came and hang out. Thanks Big Vlad.
It was wonderful to have somebody else who'd actually played the game, because I don't think there's a whole lot of us in the world.
Not yet, but there will be more.
Anyways, have a wonderful night, everybody.
Yeah, see you all next week.